something. If you are working portable, 12 volts is good, but maybe we may have a version in future just that can be powered from a power bank, yeah, 5 volts, and then it may work. Here, the RX antenna comes directly in. It has the bias T inside, so you don't need to use any external bias T. The 12 volts from here is used directly to supply 12 volts to the LNB. This is the RF output of the transmitter. If you want to use the rest of the amplifiers, you just put a cable between these two, so it uses the onboard amplifier. All are laser cut, possible aluminum drawings are on the page as well. So we just checked what we did, and yeah, it's software defined. Yeah, better than the previous version. It's software defined. Is it portable? Yes, I can carry it. Cheap? Yeah, cheap. I don't want to put it a price, but you can search for the component prices on the net, and you will see the most expensive part is the amplifier, then the display. The rest is all below 10 euros. So it's cheap, I believe, and it will change the way we are getting to the satellite. Simple, yes, kind of. Expandable, battery powered, stable, we'll see. You will test it and we'll see how stable it is. It's open source. We did it with friends. We had fun. It's collaborative. It's non-profit. Then, current situation. We have a basic firmware. Of course, we copied a lot from Klaus and Argenta Marvel, but we had a different design, kind of a different design, and so we had to implement a lot of things from scratch. For example, the display drivers, we had to implement them from scratch. So now it's capable of doing a two-way communication easily. Frequency steps are good, but the display is, how can I say, when you go, let's say, kilohertz by kilohertz, you see the frequency selection is moving. When it gets to the 10 kilohertz, because it's a step to the next on the VCO, then it goes to the beginning and gets everything back. So it's not a good visualization on the device now, but in future we will develop a better HMI for it. So we have a very powerful display on it. We can draw whatever we want. We are thinking about putting a split screen on it of our faces that we did this during the start. We have enough memory. HMI controls are working. Inter-MCU communication is working, so transmit and receive Raspberry Pi Pico MCUs are talking with each other. We developed the QO100 version first, not the VHF, not the UHF version. For 10 GHz reception, you can use just an LNB and plug it in. For communication, you just need a dish, maybe sometimes not. An LNB and a TX antenna, that's all you need for proper communication. Aluminum case design is completed, you can see samples here. So, why QO100 first? I think I said it in the beginning. There are already ready-made devices or radios in the market that you can buy to work on VHF or UHF or SHF, but there are no ready-made QO100 devices. So we thought that it will get more team members into the team to develop this and get it alive. A lot of people would like to try it, and nobody will compare us with this brand or that brand or that brand. So it will be its own brand. If it's doing the job, it's doing the job. And we can improve it by adding new capabilities on the top of it. So we choose QO100. That's one reason. The other reason, as I said, Turkey is an earthquake country. In the last earthquake, we sent people to the field to have a QO100 communication, but it was it was another disaster on our side because people were not able to get the laptops up, get the Bluetooth up. It was, they messed up, they just connected everything in the wrong direction, even we sent them all the drawings and everything. So I thought, yeah, this device, maybe a device that you can keep in the trunk of your car or in your, let's say, suitcase or somewhere near you. It's small, you can have a dish, small dish with you, and when something happens, you just get this out, put the antenna, direct the antenna, apply the power, and it will work. People should not need any expertise to get this working. So that's why we started this QO100, to show that this might be a good aid for the disaster communication. Known improvement requirements, we started designing the HMI to change it. Bob had an idea to put some Nixie tube emulations on it, just like Nixie tubes on the skin. Those all will happen, I guess, when you start downloading this. I think I did how can I say,
presentation.
Yeah, I sent some pictures of that. I drew some Nixie tubes in these digits and said, yeah, it's working, but just don't put it into the proper firmware. But yeah, people will work on this. People will try on this. Maybe they will draw Nixie tubes. Maybe they will draw peoples as characters. But it's up to you. It's open source. So we need to find a new PLL. We have an IQ modulator leakage, local oscillator leakage. It's a problem normally in this kind of designs. First I thought it's because of the local oscillator is directly leaking to the amplifier.
First you thought my PCB design, right?
So I just covered all parts of the synthesizer not to have any leakage to the outside. I lowered the power to the minimum. I tried to apply the local oscillator from some external sources. Then we figured out that it's not there. It's somewhere in the balancing of the IQ, most probably, which is causing us a local oscillator leakage, which we need to work on it and dig it and solve it soon. But even with that leakage, you can communicate because it's a little bit out of the band. When you start talking, and if the other party has a good filter, they don't hear the leakage on the satellite. You transmit a carrier with you, like an AM communication, and you modulate the SSB on the side. Kind of working. The AGC part has some problems. We need to improve the AGC approach on the device. So we will have a demonstration, so you will see the AGC is not bringing back quick enough to cover the noise, background noise. What next? Extend the team. Maybe find a manufacturer, because we just manufactured a few pieces, 5, 10 pieces, and it cost us a fortune to develop those because they ask tooling for every design. So we may come together and, for example, order 100 pieces, we will get all the prices down. So I don't know how those process goes, so if anyone knows, please help us. And we are looking for enthusiasts, firmware developers, hardware developers, mechanical designers, documenters, translators, component seekers, logistic experts, commenters, reviewers. It's you. We are just looking for you. Please join us, just comment us, or come and do something with us, and let's improve it. So, last part. Are we on time? Yeah. We have a demo set up on the table. On the right side, left side, you see the N3B here with a microphone. Of course, there's a demo effect, and we are not able to transmit it. You see now. We are at A1291 in Turkish Radio Amateur Club booth. When I go back there, I will fix the system, so maybe today, a few hours later, you will see a fully working device there, transmitting and receiving, so keep this in mind. Yeah, on this side we just apply the 12 volts and the output is on this side. So let's open the. Yeah, this is the SSP background noise. That we will work on that because it's the ADC going back under the PVMs. What I will do is I will take this off. Because I will have more amplified voice. So what we have here is, we tried to simulate the QO100 setup. LNB generates a signal with 9,750 megahertz IF and down converts everything to 739 megahertz. So if this device can receive 739 megahertz, that means it can receive the output of the LNB. On the other side, we transmit from 2.4, so we can listen that with an SDR console and an add-on Bluetooth. Here I have an SDR console setup that my headset want to connect it. So I will start transmitting from this device, and it should listen. Yeah, test 1, 2, 3, test 1, 2, 3. Doesn't that happens? Test 1, 2, 3. Let's see what's the problem. That solves the problem sometimes. Test 1, 2, 3.
Murphy's in action.
1, 2, 3. It was working before the presentation. Yeah, test 1, 2, 3. Yeah, test 1, 2, 3. All. Test. Yeah, this is on this side. 1, 2, 3. Error feedbacks.
Questions. First question is the first question is the demo, the very large latency, considering it's only going from one end of the table to the other, that's almost comparable to the satellite itself. Is that latency issue going to be addressed?
The latency, it's on both sides. So I'm using the Bluetooth, we have a latency here, and also on the other side for the IQ demodulation, we have a latency. Yes, it will never be zero because we have some delay there, but it will not be this big. It will be addressed. For now, already having the satellite latency, let's say roughly 500 milliseconds, if you put a 200 milliseconds on the top of that, we may be okay with that, but on this demonstration, yes, we have some.
Okay, I've got it. And I'm a now elderly analog engineer. What is the unwanted sideband suppression on both the transmit and receive?
Didn't measure those yet.
Okay.
So, as I said, the performance, we will do it. Some people will build this device and they start measuring it. Maybe we will improve it. This is just out of the, let's say, atelier, just out of the workshop. We just built this and it's here. We built everything
In 3 months.
in 3 months. And my plan was to fix a lot of bugs while driving here, because we came here with a caravan, and I thought we will stop every day and I will have time in the evening to do some coding. That didn't went that way. Even one line. So, yeah.
Do you have an HDMI output to connect a larger screen?
No, because this is a Raspberry Pi Pico, which is roughly €5. It doesn't have a screen output. Maybe in the future we can move to Raspberry Pi Zero, which is more expensive, but we can do those. Any other?
In terms of the reference crystal oven, will it be easy to replace with a better spectrum?
Yeah, it is.
and the GPS PO, will it expect to see square wave or a sinusoidal wave, or will it take over?
Both works with this, yeah. But for this one, we just wanted to use what is in JLC-DCB. It's half a euro or 0.1 euros. Just put it there.
Yeah,